All I need from you right now is just your eyes up here. Your mouths are quiet. I want you to listen. Your phones are put away. Your full and undivided attention up here so that I can tell you about my least favorite Winter Olympic sport. My least favorite Winter Olympic sport. And I'll tell you that I've been telling this story for a long time, and I don't think anybody's ever guessed it. I'm going to give you 3 guesses. Who's got a guess? Least favorite Winter Olympic sport. What do you think? Dawson.
Curling.
Every single time, you guys, I'm telling you, every single time I do this, the first guess is always curling. And that is the least true. Oh my gosh, I love curling. And you guys, okay, so here's the thing, because we were talking about this last period. Here's the thing about curling. You have to give it a chance. Because if you just watch it for a second, you're like, oh, this is really lame. But friends, curling is really cool. There is so much physics in there. And there is so much exacting motion. You don't believe it until you try it. And then it's really, really hard. Curling is not my least favorite Winter Olympic sport. In fact, I actually really like watching curling. All right, I need another guess. Andre, you had your hand up. Skiing. Also really fun to watch. Also, like, they go fast, especially ski jumpers. Whoa, like I could not do that, but it's amazing. All right, I see lots of hands up. I'm not sure who to call on. Grace, you seem really excited though. Which is amazing, isn't it so cool, right? They go so fast, so fast. Holy cow, there can be collisions, there can be crashes. Super fast. Let me tell you, I'm just going to tell you, because we don't have a ton of time. Let me tell you what my favorite Winter Olympic sport is.
I thought you said least favorite.
Least favorite, sorry. Least favorite. Least favorite. It's true. The only reason it's my favorite is because I bring it up all the time. But it isn't. It's definitely my least favorite. Least favorite Winter Olympic sport. Ice dancing. Did you have that? Were you saying that? Yeah. Now, I have to be clear. Were you saying figure skating? Because this is the thing, you guys. And this is like my public service announcement to you for the day. Figure skating and ice dancing are not the same thing. So how? That's what you want to know. Let me tell you. So here's the thing. Shh. Guys, you gotta be quiet because we don't have a lot of time. So here's the thing. In figure skating, people can jump, people can like spin, they can do all kinds of things. And especially in pairs, figure skating, they can throw each other. And that's awesome. That is fantastic. If you have not watched the movie The Cutting Edge, put it on your list of movies to watch on the snow day. Right? It's fantastic. Here's the trouble with ice dancing, as I understand it. And I want to be very clear that there is no disrespect to anybody who has a connection to an ice dancer or who is an aspiring ice dancer, because friends, I could not be an ice dancer. I want to make that really clear. Here's the thing about ice dancing. It's always a pair sport, which is fine. But my understanding of the rules, and correct me if you know that I'm wrong, because I think this is right, that each member of the pair has to keep at least one skate on the ice at all times. The fundamental, are you telling me that's right? Okay, good, because I didn't know for sure. I thought that was true. The fundamental problem with that, are you with me here? They can't jump, like they can't do like triple axels in unison. They can't throw each other, which is, let's be honest, the most exciting part, okay? And as a result, ice dancing has this identity as kind of a foofy sport, okay? And I will tell you that 90%, I'm pretty confident in that number, 90% of all ice dancing routines start in the same way. Caleb, will you be my ice dancing partner? Come here. Let me tell you how they start. And I have to be honest, you guys, I am the person, like in my relationship with my partner, with my husband, where like if we're watching a movie, like if it's a romantic comedy, fine. But if it's like an action movie and then they like tack on the love story, like that is not my thing. Like seriously, just like make something happen and blow up. Like that's way more fun. Okay, so anyway, the problem with ice dancing is that they all, 90%, probably not all of them, start the same way. Here's how they start. You ready? You my ice dancing partner? Stand like this. Okay? You know what I'm saying? And Yeah, and so they stand like this. And then the problem, you just stand right there for a second, is that they stand there and they like gaze into each other's eyes. All that goofiness, right? And then, you know what I'm talking about though, right? Like this happens. And then, so they stand there like that and they're gazing into each other's eyes. And then, what do? You just said it. They push off. And so the only thing, you can sit down, thank you so much. The only thing that they, like the redeeming factor of ice dancing in all of its glory is that there's a little bit of physics there that's interesting, okay? And so we're gonna talk about that little bit of physics. I'm gonna hand you a bright pink piece of paper. It's got something printed on the back, but I want you to use the blank side for now, okay? So I'm gonna hand you a little tile, count the back, bring them up, you know how this works, right? So you guys are gonna go 1, 2, 3, and then I'll give you 1, 2, 3, 4 right here. 2, 4. So you have your pencil out. There we go. That's okay. All right. So friends, I need your full and undivided attention right up here. Here we go. So when I was a kid, just bring them on up if you're done. When I was a kid, we didn't have Netflix. We didn't have streaming anything. So I know, right? Like, it wasn't even that long ago. Let's be honest here. So it's weird to imagine. So when the Olympics were on, the Olympics we watched, and if it was ice dancing, then we watched the ice dancing. And when I was a kid, ice dancing was dominated by Russia. They were really, really good at it. And so I'm going to give you an example about a famous, big air quotes, group or pair of Alice and Boris. So we're going to talk about Alice first. So we're going to go ahead and draw. Oops, we don't want that. We want, come back here, friend. What's that? We're on the blank side, not on the side with the chart. We're going to do the chart in a minute, but not yet. On the blank side, here it comes. Here's Alice. You're going to draw a picture of Alice as well. There's her head. There are her skates. Okay. And this is before. Yeah, you draw this. And friends, if you want to just draw it as a dot, you can. Because guess what we're going to do? We're going to draw a three-body diagram. Yes, because we haven't done that for a long time. Not all year. So here we go. Alice is standing. I know, right? Alice is standing on the ice. Boris isn't even there yet. What forces are acting on Alice? Gravity. Awesome. That's the force of what? The force of the earth on Alice. And you've been asking for a long time, why do I have to write the force of the earth on Alice? This is it. This standard is why we care about that. Writing this over and over and over. This is it right here. Force of earth on Alice. Now, anything else acting on Alice? The force of the ice. Which way is that one going? It is indeed. Force of the ice on Alice. And this is a what kind of force? Normal, and this one's a gravitational. We good? Net force in the y direction. What does it add up to? 0. F net in the y direction on Alice has to equal 0. How do you know it's 0? One is negative, one is positive. One could be bigger than the other, right? What's she not doing? Starts with an A. She's not accelerating, right? F equals ma, and A is 0, so that means S equals 0. So Fg plus Fn has to add up to 0. So far, so good? On comes Boris. Here he is. So I'm going to draw Boris over here. I'm not going to put them right next to each other because I get confused if they're too close, but you can imagine that there they are. There he is with his skates. Yay. What forces are acting on Boris? Same, right? F of the earth on Boris. That's a Fg. Bless you. And we got the force of the ice on Boris. Fn. What's the acceleration of Boris right now, friends? In the y direction? 0. He's just standing there. So F net is 0. F net in the y direction. Whoa, hello. I don't know why it does that sometimes. That's weird. F net in the y direction for Boris is equal to 0, which is F. What is going on? Wowzers. Fg plus Fn. All is well. So now, the most nerve-wracking part of being at the Olympics and ready to perform is when they go out there and they stand there and they're gazing into each other's eyes, and then they have to sit and wait for the music to start, right? And Anna and Ashley, I'm looking at you, right? When you stand there, and like you're doing any sort of performance, you have to wait for the music. It's like excruciating, isn't it? Like, come on, come on. Now, luckily, they got to gaze into each other's eyes the whole time. So that was nice for them, I guess. But anyway, they're just waiting and waiting and waiting. Finally, when the music starts, then they get to push, right? Right now, their net force is 0. But as soon as that music starts, what happens to Alice? Where does she go? She going that way, right? There she goes. If she moves, her momentum right now at the beginning before the push was 0, and now she's changed momentum, which means that there had to be a force. Do you agree? Yeah, there had to be a force acting. Who caused that force? Boris did. Let's draw it. So there's a force of Boris on Alice, and F net in the x direction for Alice is equal to FB, the force of Boris. And is she accelerating? Is she going to accelerate? Yeah, she's going to speed up, isn't she? Yeah. There she goes. Woo! All right. The music starts. Alice starts going this way. What happens to Boris, you guys? He goes the other way. Why do we like to do this on ice? Because there's no, you got it. So here we go. So we got Boris. He's got a force. It's the force of Alice on Boris. Okay, also an applied force. F net x for Boris is the force of Alice equals ma for Boris. Because they're accelerating, it's okay. F equals ma. Does that make sense? Yeah. All right. Is the setup making sense to everybody? I've got 3 questions for you. Here they come. Question number 1 is who pushes first? Question number 2. Oh my goodness, you okay? You can go drink if you need to. Who pushes longer? And question number 3 is who, that's supposed to be you, pushes harder. Okay? I'm going to give you just a minute to talk to your table mates, see if you can answer those questions. I would like you to write down an answer. It doesn't have to be the right one. If you're not positive, go with your gut, use your physics, and see if you can answer those questions. Answer those 3 questions. I'm going to give you just a moment, then we're going to move on.